Section 5.3, page 3, the last page. So we're going to go ahead and look at two more examples, the first being example 4. I'm asked to evaluate an integral, which I recognize as a definite integral from 0 to 2. And when I look at this function that I'm evaluating, had it been a derivative, it would be a product rule. So does that mean I could simplify it? We're not taking a derivative, but somehow that's my personal reminder that I need to simplify first. So I'm going to distribute the 2w to the 4w squared and to the positive 1, the negative 3 to the 4w squared and the negative 3 to the 1. As I multiply each of these terms out, I notice that I have no like terms. So I'm going to have to take the integral from 0 to 2 of these 4 separate terms, and because my variable appears to be w, it's dw that I'm integrating over. So taking the 8w cubed, we add 1 to the exponent to get 4, which means we have to divide by 4, and 8 divided by 4 is 2. Taking my 2w to the 1 power, adding 1 to give me a 2, I divide by 2, but I can cancel the 2's to get that invisible 1. Now when I have my minus 12w squared and add 1 to the exponent to get a 3, I'm going to again simplify by dividing 12 by 3 to get that minus 4 because of the existing minus sign. And remember, whenever we have a constant, we put the variable in to the right of that. I'm still integrating from 2 to 0, and this is just my nice reminder. So I've got my cleaned up function that I'm ready to evaluate at f of b minus f of a. So plugging 2 in where all the variables are, plugging 0 in where all the variables are, and remembering to subtract those answers or those evaluated components, I've got negative 2 minus 0, which is just negative 2. What this tells me is more, or possibly all, of this shape, of this sketch, would be below the x-axis, or more of it is below the x-axis than above because of having a negative answer. I could turn around and try to sketch this to verify this, but maybe on the next one. The last example, number 5, same directions, but the thing that should catch your eye in this problem is we have an absolute value. That means that whatever x gets plugged in, we're going to need the positive version of that value over the interval from negative 1 to 2. So the absolute value to always be positive will just be x if x was positive, or we're going to need negative x because we're going to take the negative of a negative for any negative x value. Now, I chose to put greater than or equal to here. I could have done x greater than 0 and x less than or equal to 0 in the second piece because we know that 0 is neither negative nor positive, so it didn't really matter which one the 0 is in. But the important part here is we're breaking up the integral into 2 regions. So this is where x is less, so I said less than or equal to, sorry. X is less than 0 is going to be one of my regions, and where x is greater than or equal to 0 is going to be my other region. So notice we have square brackets here, even though we don't have or equal to in this second piece. So I'm going to have my integral from negative 1 to 0, where I'm treating x as negative x. So again, my negative times a negative turns into a positive. And then I'm adding, very important, talk about that in a second, my integral over the second region of 0 to 2, where I know I'm plugging in a positive x value, so I can just go ahead and use x. Now, I agree that it's f of b minus f of a when we're evaluating at an individual point, but remember, this is where we're combining 2 integrals, so we need to have a plus sign. So focusing on just this left side, I'm going to say I've got a negative 2 times a negative x, which is positive 2x. I can add like terms to just get the integral of 3x. Treating 3x as having a positive 1 exponent, I'm going to add 1 to get a 2 that I need to divide by. So I have 3/2 x squared that I'm going to evaluate at f of b minus f of a, right? So this is my larger x value, my smaller x value, and obviously anything times 0 is 0, but my -1 got squared, so I have a positive, but I'm subtracting this piece. So just this first integral, total area is -3/2. Now my second integral, again, there's really nothing to distribute. I just have x minus 2x, which I can add like terms to get -x. Assuming that -x has an invisible 1 exponent, adding 1 to that and dividing, I have -x squared over 2 that I'm going to integrate between f of b minus f of a. But remember, they've changed because my larger x value is now 2, and now the smaller x value is 0, whereas in the previous one it had actually been the larger. So because the negative sign is outside of the x squared, this is going to give me a 4, but it's going to cancel with a 2 to just give me a 2, but I'm going to have -2, and then 0 squared and dividing by something will always be 0. So I really have -3/2 minus 2, although maybe I need to think of that as -4 over 2, so I can combine my numerators to get -7/2. Again, without graphing this, I know that more of my answer is below the x-axis, but possibly all of this is below the x-axis.